So as Anne introduced me, I'm an assistant professor of digital heritage and metadata at the University of Antwerp, and I will be talking about geospatial linked data today, or linked geodata, as we can also call it today. And I hope I try to keep it as an introduction to linked geodata level. So I hope that speaks to the needs of the audience today. Thank you. So we could perhaps, I assume that today we have quite an heterogeneous audience. We could perhaps start from a very simple but obvious, very important question: what is geodata? And I just gathered two simple descriptions here. Geodata is information about geographic locations that can be processed by geographical information systems. And that's a description given by Esri, a very well-known desktop GIS software company, ArcGIS. And then a second definition, which is from Wikipedia. And then geodata is data and information having an implicit or explicit association with a location relative to Earth. So from these descriptions, we can see that geodata is information about location of things, obviously, but what makes it different from spatial data, which is also information about location?
Yeah. I'm sorry to interrupt, but we still see the first slide. Could you move to the next ones and put them perhaps also full screen?
You can't see the.
We see your presentation, but still the title page. The first.
Oh, really? It didn't move. Oh, that's very. Okay. I will try again. It's strange that it's not working.
Yeah.
I will try again, because I see it as full, but.
I think if you put it on slideshow, then perhaps, yeah, perfect. Yeah.
Okay, excellent. I'm very happy. It's very relieving that it worked. Yeah. Okay. And then this, I'm sorry. And then the second one is that. I'm very sorry. This is not. Okay, and then the second.
If in your menu you click on the slideshow, and then from
it's gone. Is it gone again?
No, we see it, but we still have the tray on the left.
Sorry, I can't see. Is it you can't see the presentation well?
We see the presentation, but if you go in the top menu with slideshow, then you would see it full screen. Thank you.
I believe that the problem is that you are sharing the PowerPoint window, but when you put it to the presentation mode, it actually creates a sort of a new window, and that isn't shared. So if you share your whole screen, for example, then we can see it.
I will try to share the whole screen.
Thank you. You see synergy in learning.
Yeah. Entire screen. Okay. I think now it should be okay. Now I think now it will be hopefully okay. Is this okay now?
Perfect. Thank you.
Okay, excellent. Okay. So the geodata was geodata. So it's spatial data is something, of course, it's about location spatial data, but that's the overarching term for which includes geodata as well. But geodata is basically data with geographic location. So you can locate things on Earth unambiguously. So that's basically geodata. Now, geodata has been typically handled with software that's known as GIS software, Geographical Information Systems. I think many of you here will probably be familiar with GIS, but we could quickly describe Geographical Information Systems, desktop GIS, basically as any piece of software that is able to manage, display, and analyze geodata. And GIS typically works with layers. So the GIS has very powerful techniques to do these things, like to manage geospatial data, to display it, and to analyze it. but at the end, desktop GIS, which are like some of them you will know, perhaps QGIS, ArcGIS, they are basically relational databases with a cartographic component, with a cartographic interface. Now, that means that issues with aggregating data in relational databases then immediately becomes an issue for aggregating data in the case of GIS, where the database, the relational database, is called geodatabase. So it then becomes which issues you have with integrating data in different relational databases, you will almost or completely copy it to the case of geodatabases. So in 1990s, 2000s, of course, GIS was in social sciences and humanities very prominent. Also in heritage sector, it still is. But because of the non-scalability problems when it comes to aggregating data in the case of geodatabases, it often, like we would work in humanities disciplines, in heritage institutions, and we would often face problems with aggregating these data sets. So large or small geodatabases could, of course, in principle, be linked to one another, but there would be some typical issues in data integration, data aggregation, which was caused by the heterogeneity of data sets, which, for instance, would manifest itself with different data set schemas. So it would be too cumbersome to integrate the geodata in these databases. So they would basically be very, the integration setup would often be quite non-scalable. Now, just to give you an idea about what kind of issues you could face when you would like to integrate several relational databases, I want to take you to the domain of SciDoc CRM, which is an ontology which is compatible with RDF. I will be coming back to briefly at the end of this presentation, but there's a really nice part of SciDoc CRM's history that's told by George Brusaker et al., where they are telling about where SciDoc CRM as an ontology came from, and actually the very place where SciDoc CRM came from is actually related to the problem that I have just mentioned. So what ICOM, International Council of Museums, were trying to do was they were trying to, several museums in the GLAM sector had their own databases, often in tabular format and often relational. So they had the intuition, obviously, that there would be to the generality to the domain of museum information. So ICOM had the attempt then to build a database prototype that would meet the needs of the entire museum community. So they wanted to obviously give a schema that everyone could fill in. But then the resulting work was an impressive, it was a huge and grandiose work. And in the end, they ended up with 400 tables. That was difficult, obviously. That was a database schema, a relational database with 400 tables. That was very difficult to put into practice. So they then came up with the SciDoc CRM ontology instead. Now, why I'm telling this to try to give some understanding of how difficult and how, as it is called here, maximalist effort can be to try to aggregate geospatial data in geodatabases without linked data technology. And this was, as I said, a problem that we would face again and again in various contexts, in GLAM or in research contexts. So obviously you heard a lot about linked data, and then you will hear more today. But what I would like to emphasize is that linking data via places, via location, via geodata can be surprisingly effective way to aggregate data. Hence the spatial role of linked geodata in the linked data community, because linked data sets can be linked through persons and events as well. But because a lot of data sets have a geographic, a spatial component, among other reasons, linked data can be a surprisingly effective way to create a linked data geodata can present a surprisingly effective way to create a linked data ecosystem. So that's why I think today also I was invited, for instance, among others, we do not hear linked events data, but we are more talking about linked geodata, because spatial data together with time perhaps, or spatiotemporal data even more so, is a very important part of any data set, but especially in the context of GLAM and I would say also digital humanities. Now, I hope Anne doesn't mind this. We had this email conversation yesterday, and then I found this really interesting and really spot on. So I would like to quote what she said in the email. She said a very interesting aspect of geospatial location for cultural heritage institutions is the fact that you manage to identify a certain location even when the name country changes throughout time or varies according to language. So that's indeed, I thought this really captured one of the very special nature of geodata in the context of creating, trying to create linked data ecosystems. So I do not want to, because I want to show a lot of concrete examples today, so I don't want to dwell on this issue too much today, why geodata is so important. But there's a bit of literature there, but just I think it would be good to take that home to from here today, that it is the case. So it's indeed certainly true that in many GLAM institutions and heritage sites today, like archaeological sites, historical sites, thanks to the digital services these institutions help building and these institutions currently use, like I just put Cartesius here, which KBR contributed and worked with, which presents plans and maps and photographs of Belgium and Central Africa online. So there is a great potential for linking information sources to one another through places and linked data. But how that works exactly, that's what I want to concentrate on today a little bit, because I also saw in the chats when I first came in that there was a lot of, I think for a lot of people, this how linked data truly works can be a little bit foggy. So that's something I want to really concentrate on today in this brief talk. So if in 1990s, 2000s, we started to work with GIS, we finally were introduced to this concept of geodatabase, how interesting it is that we can visualize large chunks of data in a very nice way on a maps interface. But as I said, it was not scalable, it was not difficult to aggregate data, I think we may now have, we probably have the right technology now to actually deal with geodata and integrate it at different granularities. So granularity is something you may hear often in the linked data context. What is granularity? So if you look at here in the database table, which I found online, you have different scales of geodata in the red frame that I put. You have states, cities, street names, street number. As you can see, it's getting smaller and smaller, the spatial features. So this is what is called granularity. So you can link data on the base of states, you can link data on the base of cities. These are things that are sort of working quite well at the moment in GLAM institutions and elsewhere. Whereas as I will come to the topic of digital gazetteers in a minute, you will understand what I will be saying now a bit more, I think. But creating a digital gazetteer for street names and down to the level of street numbers, that level of granularity is something we are still dealing with. Or as an archaeologist, I can say in an archaeological site, having a granularity down to buildings or even archaeological spaces or even stones on site, for instance. That's when I say granularity, it's about the scale through which the resolution of linked data, if you like. Now, but how is it done really? So how do we link digital resources with geodata? Well, usually the most important thing in a linked geodata application is a list, having a list index of all locations that can be used to link data. And these indexes are called digital gazetteers. So I'm showing here one of the well-known digital gazetteers, GeoNames, and for the entry Vicksburg in United States, it's showing us. I will be showing. So it's listing places that is called Vicksburg to us. So at the minimum, I mean, you can have different digital gazetteers, and different digital gazetteers can have different data models. But at the minimum, a digital gazetteer includes a unique and persistent identifier for each of the places that it lists, so that it can be unambiguously identified by computers and by humans. And a geographic coordinate, obviously, to again unambiguously locate this place on Earth. It then becomes possible to tag or annotate the place names in, for instance, digital geodatabases, digital texts, newspapers, images, and other resources with this unique and persistent identifier. So all these resources get linked to one another. So it's actually this unique and persistent identifier has a, and I will come to that as a name URI in linked data terminology, but it's in the end not very different than an ID in a relational database, but it is something that is used by the World Wide Web. So in that sense, it is global. Now, so this is how GeoNames, when you go, it's basically a website. You can like look for Vicksburg and then lead to the page that I just have showed to you and have shown. And if you go and click on Vicksburg, the Vicksburg that you think is the right Vicksburg in the list, then you say that to GeoNames that you would like to see this site on the map, then you get something like this. It shows you all sorts of information, but importantly, what is there is also RDF, which is the linked data file, basically resource description framework file. That is basically what makes GeoNames a digital gazetteer compatible with linked data. Now, if you go in and look into RDF, what is in this RDF file, you will see a lot of information marked up, and including, for instance, I'm just showing bits and pieces of this marked up file, but including alternate names for this particular place, Vicksburg. But also, very importantly, it also has a certain ID for Vicksburg, which is the Uniform Resource Identifier, which is this unique, persistent and unique identifier for this place. And the idea of linked data is obviously to be able to tag, annotate your digital resources with this unique identifier for this place, so that, and I will go even a bit more, give more examples in this, so that in the end you can everything that's about Vicksburg can be called through a query in your web service or whatever service that you are building with linked data, let's say your linked data ecosystem. So this is all nice, of course, but I also have to mention, of course, when I mean the idea is great and and the technology is great, but of course there are sometimes issues with this, in the sense that there are, for instance, GeoNames is obviously not the only digital gazetteer online. So you can create your own digital gazetteer and give a persistent and unique identifier for Vicksburg yourself. And as a result, for instance, there is GeoNames as a digital gazetteer, but there's also Getty's Thesaurus of Geographic Names online. I'm just counting few of the digital gazetteers. There is DARE, for instance, another digital gazetteer. So there's Pleiades. anyway, so if you go to Wikidata, indeed, you can, for instance, for a site, for a place like Athens, you can, as of 2 days ago, you could see more than 60 identifiers for Athens in Wikidata. Not all of them compatible with linked data, not all of them URIs, but still. So there is something called, because there are so many digital gazetteers, there is an issue called gazetteer alignment, because when you build a linked data ecosystem where you link information through geodata, and this also goes for other like persons and events, etc., that you need to be able to say that this URI from GeoNames is also equal to or same as the Getty Thesaurus of Geographic Names Online. The other, you can see, for instance, here the two different URIs for the case of Vicksburg. So you should be able to align these different gazetteers that your system will use, so that if you want to aggregate data from other sources which uses various digital gazetteers, basically. So there's an issue called gazetteer alignment. I think that is important, that we need to be aware of here. Now, but let's have a look at again how it really works. This could be a good place to start with. I have a very simple example from Ariadne Plus. There, with their courtesy, I'm using this slide, and I find this a really good visualization of how that really works. So you see, for instance, I hope at least some of you are familiar with Ariadne Plus, which is like an archaeological data infrastructure that uses linked data technologies. So you see here a database from Ariadne Plus from Cambridge, like from a museum in Cambridge, Roman and medieval coins. So this is a denarius, for instance. There's a database and there's an entry there. It's a denarius, it's silver. It was found in Pompeii in 1883. So now at the bottom, you see a lot of controlled vocabularies and ontologies that this database is mapped to, and that's something we will not have time to talk about today. I think that's a lecture in itself. But just for now, let's concentrate on this denarius. It was found in Pompeii, and then there's another database that comes to Ariadne Plus, or can come to your institution, your service, and then there is then this time an amphora from Pompeii as well. And again, you see that this is mapped, this information is mapped very nicely to different controlled vocabularies and ontologies, including Getty's Arts and Architecture, Thesaurus, and Pseudoxera. Now, first, obviously, you will, I think, know by now that linked data works with graph structure. So first, when you model your data, it becomes a graph, and then this is how that denarius looks like when it's modeled using the ontologies and controlled vocabularies. So this is the denarius, and then when you go and bring the amphora, you can see that now the two artifacts from this archaeological site, Pompeii, is basically linked to one another through the Pleiades URI that is given to Pompeii. Of course, as you see, they're also linked to one another through Periodos URI, persistent and unique identifier given to the Roman periods in Italy. At the top, you will see it. It's also they're also linked to one another through Pseudoxeram's E22 man-made object, or now it's called human-made object, and rightly so. But so there are different. So they are linked in through various relations, but place is almost always there in this kind of cases, because archaeological artifacts are never found in a vacuum. And this also goes for a lot of, as I said, GLAM institutions, which will have place references in their collections, etc. So this is just to visualize a little bit how it works in practice. Now, in a linked data search engine like the one Ariadne Plus has, now these artifacts, this amphora and coin from two different databases, can be accessed when artifact coming from or associated with artifacts coming from or associated with Pompeii are searched for. So I hope this makes it a little more concrete how this exactly works. Of course, this is one of the many cases how it can be configured and worked with. Now, so Ariadne Plus, as I said, for instance, has a search engine for linked data. Another one is such linked data search engine actively used by archaeologists and ancient historians is Peripleo from the Pelagios community. For instance, here you can search certain artifact types in various databases and documents annotated by the Pelagios community. And the map-based search engine will display temporal, spatial, and attribute information about that particular artifact. So as hopefully you can see here. And this is thanks to the digital resource of those artifacts being annotated, among others, using a digital gazetteer. So people annotate their data saying that they came from this place, that place, using a digital gazetteer. And as a result, Peripleo search engine is able to display the data in this way. At the moment, if you want to go and search Peripleo, it's down because it's being updated. So I want to give that warning as well. Now, we talked a lot about databases until now, but I want to make sure that, and I'm coming to the sort of the end of the presentation to talk, but I want to emphasize that there are other digital resources where we can find place references and couple them with geodata using digital gazetteers. So two typical other places you regularly find place references or even geodata is images are images and texts. So you can make images and text part of a linked data information ecosystem by annotating places as well using information coming from digital linked data gazetteers. So here again, I'm presenting you with another Pelagios communities, another web application, Recogito, which is very well known by digital humanities community, a really very user-friendly, very intuitive user interface. And here you can see, I hope, more or less how different places are annotated. So this is from Iliad. So different places mentioned in Iliad are annotated using the Pleiades as a digital gazetteer. And then in the next one, you have again Recogito, and this time the annotation of places in an image. This is a map image, so this is not a map, this is not georeferenced, but this is a map image annotated by Recogito using, again, a digital gazetteer. Now, if we have a look at what kind of outputs a web service like Recogito can give, it's several. Of course, CSV is there, KML is there, but there's also RDF, different RDF serializations, including RDF XML. So you can extract your data, export your data as linked data from Recogito. Now, if we again go in the RDF file and look what is in there to understand a little bit better how this all works, you will see in the red, each time the persistent identifier of the image in red is associated with the persistent identifier of the place that has been annotated as through the digital gazetteer. So you have the image and you have the URI from the place. So we have three different URIs in blue because we annotated three different places, and then one in red for identifying the image, basically. So just to remind you how it looked, these are our annotations, and that's how the RDF looked. Now, so it becomes, so let me tell a bit clearly that if there was now a search engine for all documents annotated by the Pelagios community, which doesn't exist at the moment as far as I know, it would be possible to find this piece of text, this manuscript, for instance, or this, for instance, this could be a newspaper piece as one of the text pieces annotating places, Chalcis, Eritrea, or Hestia. So it's important to realize that by doing this, by annotating, we then set in a machine readable way. We told the machines, and we told also to humans that actually there is a text here which includes information about these places. So if a search engine would look for it, they would find it. The engine would be able to find it. So that's basically more or less how the entire thing works. Of course, there can be the applications can be very flexible and can look very different from one another, but this is one good example, I think. So some interesting questions linked geodata allows us to ask is, what are all the text and image sources related to these places in this collection? So this can be a corpus, text corpus, or image collection. Which places are most represented in this image text collection? And which images, texts are mainly about places in this region? So these are some of the important, very interesting questions that when you create a linked data ecosystem with geodata, often with annotation that you can work with and you can start researching with. Now, as I said, Recogito is just one of the many web services, but one very much used by digital humanities community. And it's also important that I need to say here it's in Dutch. So I know that our audience today is international, but I want to briefly mention. So plaats in Dutch is place, but it can also annotate people, persoon, and gebeurtenis, which is events. So it can annotate different, let's say, linked data classes, but there is no, in the backend, there is no link to any index with historical people or historical events. So that's something that needs to happen in the future within, maybe not in Recogito, but within the digital humanities community and GLAM sector. Now, I know that there is a data modeling topic workshop in the afternoon, but I won't mention data modeling much here because I think it's more, I mean, that's certainly beyond the topic of this talk, but as the last two slides, I wanted to just talk a little bit about that, to say something about ontologies and linked geodata. So linked data, as I said, it's a graph structure. So when you model your data as linked data, or we could say when you map your data to linked data, for instance, your tabular data, which is in abundance in many GLAM institutions in the form of spreadsheets or relational databases, you may be transforming your data structure drastically. For instance, what you see here is a data model from indeed a relational database. So you will be adding some semantic meaning to your new linked data graph as well, which will be readable by machines and humans. So what you see in the slide is one such data model from archaeology, and I hope you can see the semantic relationships between different classes, classes, and in the rectangle you will see two keys, which were basically places, like an archaeological site, and then places within that archaeological sites, which can be semantically also described as places using the code from CyDoc-CRM as E53. I don't want to confuse you or scare you with CyDoc-CRM today, so I'm not going to talk much about it, although I don't know, maybe there may be people in the audience who are more familiar with it than others. But just to give you an idea about how CyDoc-CRM works, so the data model I just showed in the previous slide is basically a data model created, a relational database mapped using CyDoc-CRM. And this is basically the class E53 place in CyDoc-CRM core. CyDoc-CRM, like CRM as a core and several extensions for archaeology, for science, etc. I showed it at the site in the pyramid-like thing. But so you can basically, when you are, all I want to say is when you are modeling your data and geodata, your data sets, which includes geodata, you are often guided by ontologies. You will have to be, and one of such ontology that's very much used in the GLAM sector is CyDoc-CRM, and I hope there can be another opportunity to talk about it more in the future. So I will conclude here. Thank you very much.